All right, we went through this yesterday. It's solving formulas, which you do the same thing as solving equations. The steps are the same. So here, the formula for the area of a rectangle, area is just length times width, right?
Yeah.
Now, length and width could also be called base and height. So when they say solve the formula for B, they're using base times height. So, what do you need, when it says solve for B, that means get it by itself. What do you got to do to get the B all by itself? Divide by H. Since it's times H, you do the opposite, divide, because then they cancel. Do the same to the other side, and then you're done. So it's A over H equals B. And you could write it backwards, B equals A over H. It doesn't matter what side. Yeah?
Would you label B with meters or no?
Yep. Since the height is meters, that would be meters. And remember, area is always the unit squared. Volume is always the unit cubed.
So B meters squared.
No? B is just a length.
Okay.
So a length is just inches, centimeters, miles. Area is always squared. Okay?
B meters.
So when we find the new base, we would plug A 128 in over H, and that's going to equal B. So 128 divided by 8 is 16, so B would equal 16 meters.
I will.
Okay, volume. The volume of a prism is length times width times height. Remember that? But they don't write that now. They write volume is the area of the base times the height. They use a capital B. And the area of a base is just length times width. That's why they just put the B in there. It's the same as length times width. So we want to solve it for B. So what do you do to get the B by itself? Divide by H, divide by H, and the formula then is V, the volume divided by the height equals the area of the base. So in order to figure out the volume of the base, we'd put 576 in for V, divided by the height, which is 12, and that will give us the area of the base. So that's 48. Now, what would you label that one?
Meters
Squared.
Meters squared, because it's an area. Okay? B is the area of the base, and area is always the unit squared. The reason why area is squared is because it's two-dimensional. If you're painting a wall, you got to buy enough paint, right? So you figure out the area of it, and then you look on the can to see how much it'll cover. A wall is just two-dimensional. You can't reach into it. Volume is three-dimensional. It's space inside. You can reach into it. That's why it's cubed. Okay?
Those cubes can fit in this.
All right, so we got a bunch of these today. We have equations with x's and y's in them. And you're going to solve for y, which means get the y by itself. So, we got to get rid of the 2 that's hooked to it, and the 5x that's not. Now, does everyone know which one you get rid of first? Anything not hooked to the letter is what you get rid of first. So you would subtract it to get rid of it. The thing is you can't subtract 5x from 6 because they're not like terms. So when you're doing these, you're better off thinking in terms of this. You can move any term across an equal sign, and you remember what happens to it when you move it?
Change sign.
It changes signs. You can move things around however you want. It just changes signs. So then this is 2y. I move that over, equals. The 6 is there. This would change from plus to minus 5x. Okay? Then, what do we gotta do to get rid of the 2? Divide by 2, and then there's 2 things here, so you gotta divide them both by 2.
You're done.
And you're done. The y is by itself. Okay? Sometimes they have easy ones like this. This is just one step. What's the one thing you gotta do? No? You just got it separate from y, so you just need to move it over. So y equals 6 minus 3x. Okay? And you're done. If they got a negative in front of it, again, all we gotta do is move this over. But then you gotta remember that's a negative y equals 2. This changes to minus 4x. So remember, if the letter's negative, what do you do to everything? Just change all the signs, right? Change this sign, change that sign, change that sign. Because you can do anything to an equation as long as you do it to everything. So, solve for y, get the y by itself. So you move the term not attached first. So it's negative 3y equals 6, and that would change from minus to plus 2x. And then it's times, so you divide by negative 3, and you're done. Y equals 6 plus 2x over negative 3. Now, if you look at some examples, sometimes they simplify this further, although you don't have to, because once you get the y by itself, you're done, which we did. But sometimes they simplify them down. This one doesn't simplify nicely, but you could. Since they're both over 3, you could do this. What's 6 over a negative 3? And then a 2 over negative 3 doesn't simplify it, but it's a positive over negative would turn to negative 2x over 3. They mean the same thing. This is how they're going to write it in the book, if you see any examples. But you can just leave it like that too. Yep. Here we got a formula. Surface area of a cone is pi r squared plus pi r L. Solve for L. So, what's the first thing you get rid of on this side?
Pi r squared.
Right, the term that's not hooked to it. You just move that over to the other side. So the s is there. This would change from plus to minus pi r squared equals pi r L. Now what do you do to get rid of the pi r? Divide by pi r. Because then they both cancel. And then you just divide this all by pi r. Okay? And you're done. S minus pi r squared divided by pi r equals L. Now again, I'm just going to show you how you could simplify this, even though you wouldn't have to. Does anything simplify S
No.
over pi r? So that would just stay S over pi r. But here, what happens to the pi's?
Cancel.
And then you got an r squared over an r.
It's 3 r's.
It'd just be an r. Because this is r times r, and there's one r on the bottom. So it would just change to minus r equals L.